Next, we have the strain legend. So this shows us ExactFlat strain legend used by the flattener to tell us visually how much strain we have on a part. You can add or remove any entry that you want from the list here. And negative numbers actually represent sag, and we have a visual preview of what the legend will look like down here. So with the default legend, gray is anything more than 0.5% sag or negative 0.5% strain. White indicates no strain whatsoever. Cyan is 5% strain. Green is 10%. Red is 15%. And red is 20% or more. We can see the effects of the strain map. I'll just turn off our edge highlights and our piece normals over here. If I were to change these, there's lots of different ways we can use the strain map to our advantage. One way is to use it to indicate a very hard limit. So if we are good for anything up to a very certain amount of strain, we can use the strain map to tell us that the second we've violated that strain constraint. So over here, instead of the default legend, we might create a legend something like this where 4.9% represents also white, but 5 represents red. And then we can remove the other entries. So now everything up to 5% is going to be white, and the second we get to 5%, it's going to go to red. So we can see the effects here. And this just very quickly tells us the vast majority of this pattern is under 5% strain, and there's only a few spots here that go over 5% strain. The remainder of the buttons here don't actually have any effect on the behavior of ExactFlat, so it's recommended just to leave them alone. So we'll switch over to the Piece Creator tab. This is where we can modify the settings associated with the Piece Creator tool. So we mentioned on Tuesday that the Piece Creator simply uses the SolidWorks surface knit features to do its merging of faces. So we have the piece tolerance and the piece gap width here. These are direct correlations to the surface knit feature. So you can adjust these however you want to help you close up gaps. It is worth mentioning though, if you do have an intentional gap or slit in your part, such as a dart, you want to make sure that the knitting tolerance and gap width are smaller than the width of your slit to avoid them being unintentionally knitted together. Below that, we have the Piece Creator naming template editor. So when we started creating our pieces, our pattern names were simply 1, 2, 3, 4, and so on. And that's because of the way the naming template is configured. There's always going to be, unless you manually set your pattern piece name, there's always going to be a hard-coded number or letter appended to the end of your piece name, and that's controlled here. You can select whether you want a number or a letter automatically appended to your piece name. Below that, we have our actual template editor, and this is where you can edit the name of your template. So the pattern piece name is always going to be in the format of whatever is in this box plus the number or letter appended to the end of it. So because this box is empty right now, I'm simply getting my number appended to the end of my pattern piece name. If I were to type something else in here, such as ExactFlat, and this is the default naming template, ExactFlat, now all of our pattern piece names are going to be in the format of ExactFlat 1, ExactFlat 2, ExactFlat 3, and so on. We can add additional modifiers to the name that help us better correlate our parts to the project that we were working on. So if you're working on a really large project, we might want to include the file name as part of our pattern piece name. This would become useful if your file names correspond to some kind of part number or project or job batch number. It can help you track your your pattern pieces a little bit better. We can also include the body name as part of the piece creator naming template. So if you have some kind of process in place already where you are creating surface bodies that are already named the way you want them, you can use the piece creator and just select the surface body explicitly instead of pulling faces off of it. And you can have surface body as part of your naming template, and then ExactFlat will just use the name of the surface body to form its name. Lastly, we have SOLIDWORKS properties and SOLIDWORKS custom properties. So if your file has a property in it that you want included as part of your name, perhaps you've got custom properties that are set with work order numbers or something, then you can set it to SOLIDWORKS custom property and adjust your sub value to select the property that you want. In the case of property, we've got keywords, we've got authors, so we can include those as part of the file name. And then for custom property, any custom property that's included as part of the file can be added to your piece creator name. So actually, I'm going to stop myself right here. I just realized I'm using the IKEA chair, not the Benson chair.
Sorry. Yes, that's I was wondering what was there. I didn't know if that was anyway. Okay, fine. So you want to just
I'm just going to carry on.
What's that?
I'm just going to carry on from where I left off.
Okay.
So for custom properties, if there are custom properties, they'll appear in the list here. If there's nothing, the box will be left empty. So let's say we wanted to include file name as part of our naming template. We select file name here, press the plus button, and that will insert the file name replacement identifier into the list. Once you're happy with your file name, you can click OK. And now when we go to Piece Creator, every single piece we create is going to be named using the file name as part of the Piece Creator name. So for custom properties, if there are custom properties, they'll appear in the list here. If there's nothing, the box will be left empty. So let's say we wanted to include file name as part of our naming template. We select file name here, press the plus button, and that will insert the file name replacement identifier into the list. Once you're happy with your file name, you can click OK. And now when we go to Piece Creator, every single piece we create is going to be named using the file name as part of the Piece Creator name. So we'll move on to conversion. Actually, I'm going to reset my name here so it's just a letter or a number. And now we'll move on to conversion. The conversion tab contains a number of automations. It's not recommended that you change any of these. The first one, assign material on convert to ExactFlat. If this is unchecked, you will not be prompted to assign a material to your pattern pieces when you convert to ExactFlat. We strongly recommend that you leave this checked. You will not be able to optimize your pattern pieces unless a material has been assigned. So there's really no reason to not assign a material to your part on conversion. Also, if you don't assign a material, then the automations that allow you to ExactFlat to automatically create a marker will not be able to engage. So it's strongly recommended you leave this checked. That way you will be able to assign a material on conversion to ExactFlat. The second option down here is more of a specialty option that was designed for a specific industry. Match material body to ExactFlat material on convert to ExactFlat. If you have a SolidWorks material that has the exact same name as a material in the ExactFlat material database, then ExactFlat will automatically use the material from the ExactFlat database that matches the body material, and it will automatically assign that material to your part for you. The default demo database does not have any matching material names, so this is something that you would have to set up yourself. So if you do take the time to set up your database, both your material ExactFlat material database and SolidWorks material database. Then there are some savings that can be had there. You can turn this on, and then during conversion, whichever materials match will just automatically be assigned. The last option here, automatic remesh. This will automatically apply either the uniform or adaptive remesher to your part during the conversion process. The default is off, and that is the recommended setting. The reason being is if automatic remeshing is occurring, you don't get to see the original input mesh, so you can't evaluate it for its fidelity. So you have no idea if it's a high quality mesh or if there are any kind of meshing errors that may be translated downstream. If you know that your meshes are always going to be a good mesh, if your parts are always very similar, then you can turn this on and it will save you a little bit of time. However, it's a good idea to check your meshes right from the SolidWorks mesh all the way down, just to make sure that you have a good high quality mesh. Moving on to the Remesher tab. This is where we can adjust the parameters and the settings of the uniform and the adaptive remesher. Starting with the adaptive remesher, we have our fidelity constraints here. So this is where we set the maximum allowed distance from the original mesh to the new mesh. These are set as factors, so the true distance is automatically computed by ExactFlat, and these are just simply multipliers that allow you to adjust the relative constraint. So surface is the maximum allowed distance between the old mesh surface and the new mesh surface. Boundary is the maximum allowed distance between the old mesh boundary and the new mesh boundary. And then lastly, minimum edge length factor is the shortest length that any edge is allowed to be created as. Minimum edge length factor is more of a suggestion. The adaptive remesher can and will violate that if it's absolutely required to meet the minimum surface and edge boundary constraints. So it's more of a suggestion, but as a general rule, it's a good idea to keep this fairly close to the smaller of these two, the surface and the boundary. We do have some additional options down here. The defaults are the recommended settings. We don't recommend turning them off. Detect short curves will attempt to detect small micro variations in the mesh, and if detected, it will preserve them. So for fidelity sakes, if you have like a small break in your part or a small change in angle of your part, detect small curves won't make an attempt to try and detect that. So it's best to turn that on to preserve the fidelity of your part. Detect narrow surfaces will attempt to identify and detect small bridges or narrow strips of surface material on your part. And when found, it will do its best to preserve that. If that option's turned off, it may be perceived as more of an outlier or an error in the mesh, and the adaptive remesher may remove those triangles from your mesh. Assume disc-like closing. We'll just assume that your part is closing in the fashion of a disc. It's not really true for most parts, so we don't recommend turning that on. It's more of a specialty tool. On closed error, leave holes. If there's an error in the mesh, if due to the nature of the way the adaptive remesher does its work, sometimes you will have errors on the interior of the part. So with on error leave holes turned on, it will just simply leave a hole in your mesh, which is not ideal. So we recommend leaving that turned off. And when ExactFlat detects that there's a hole as a result of the adaptive remesher, ExactFlat will attempt to close the hole for you. The common refinement closing is an alternate method for finishing up the adaptive remesher. It is slightly more expensive computationally. However, it reduces the chances of an error occurring on close. So we recommend leaving it turned on. The performance impact is very, very minimal, and you get a much better looking mesh free of errors using that method. So it's recommended that you just leave that turned on. Moving on to the uniform remesher. The uniform remesher works slightly differently. So we have our surface and boundary fidelity constraints. You can adjust those both in terms of smoothness and distance from the original mesh. And then down here we have our desired output vertex count. So with the adaptive remesher, we adjust our tolerance factors and it will automatically determine the number of vertices. With the uniform remesher, we explicitly tell the remesher how many vertices we want in our output mesh. So you can adjust that here. Moving on to the Flattener tab. The first section deals with tessellating, creating your mesh from SolidWorks. So this is how we can adjust the relative quality of the mesh that is being generated by SolidWorks. By default, we use automatic tolerances, and this will scale the coarseness or the fidelity of your mesh by giving a percentage value, and it will scale with the size of your model. SolidWorks, when we create a mesh from SolidWorks, you tell it what you want your minimum facet width, maximum curve core tolerance to be, and it will create a mesh according to these parameters, very much the way the adaptive remesher does. But unlike the adaptive remesher, this does not scale with part sizes. So if you go from designing something like a watch, the meshing parameters you use for a part that size are no good for something the size of an automotive vehicle, a car, or a truck. If you make that jump and you use the same meshing parameters, now you're going to have millions of triangles in your mesh for the truck. So it becomes very cumbersome. You always have to come back here and manually adjust these values to get a decent sized mesh for your size of the part. Automatic tolerances aims to correct that or remove that burden by automatically scaling these values to the size of your part. So the default is 50%, and that will give a very decent quality mesh. For demonstration purposes, though, I'm going to set this to 1%. And we are going to close the options here. And we're going to go ahead and we're just going to convert one of these pieces here. So I'll start with the backrest right here. I'll create a piece and I'll convert this to ExactFlat, and we'll have a look at the mesh just to see what that looks like. I'm just going to use laminate for car seat here. And when we open up the flattener, if we turn on our edge triangulation, we can see we have a very low polygon mesh. So if we close this and go back to our options, we're now going to go to the opposite extreme. We're going to go to 100%. And if I regenerate this mesh, this will just take a moment here, we can compare the two to see the effects of that quality slider. So now when we look at this mesh, we can see we have a mesh with many more triangles here. So this would be more ideal for use with the remesher. If we were to remesh this, we'd probably get a pretty good result. So we strongly recommend to use automatic tolerances. It's going to scale the size of your mesh relative to the size of your part, and it's going to save you a lot of work. Automatic pattern rebuild will turn on or off rebuilding of the pattern. So whenever we do something with the flattener, such as adjusting the using a pre-flattener or running the remesher, the uniform remesher, automatic pattern rebuild will automatically rebuild all your patterns downstream and update your markers to the shape of the new pattern piece. So we recommend leaving that turned on. If it's turned off, you're going to have to click the update button every single time you make a change in the flattener window, and it's very easy to forget to do that. So we recommend just leaving that turned on. It's not a huge performance impact, and it's going to save you a lot of headaches with wondering why your patterns don't look correct. The other settings here are disabled whenever automatic tolerances are turned on. So if we turn off automatic tolerances, now we have access to all these settings, and this is where we can automatically adjust the minimum maximum facet width and curve core tolerance. If you set a maximum vertex count, this will kind of limit the number of vertices that can be created. However, it creates unpredictable meshes. You can't really predict where the sacrifices are going to be made to keep that vertex count. And the last option down here, target vertex count, if this is enabled, ExactFlat will generate a mesh using the SolidWorks meshing tools. If the target mesh count is much greater than the target, it will then generate a new mesh with lower settings. If that value is much lower than the target, it will generate a new mesh with higher settings. And it's a very iterative process. It will just creating meshes over and over again until we get close to this target vertex count. So it's not a very good method for creating a meshes. The automatic tolerances is by far the best method. So we recommend leaving target vertex count off and just leave automatic tolerances on. Use legacy settings is an adjustment for the automatic tolerances. This is legacy settings is very good for developable surfaces or any kind of surface that is very cylindrical in shape. It will tend to produce very long, skinny triangles, high aspect ratio triangles that work extremely well for representing cylindrical and developable surfaces. So if you're working with developable surfaces, you might want to turn this option on, and that will actually create a better quality mesh for you. It kind of goes against our philosophy where we don't want high aspect ratio triangles, but for developable surfaces, we actually do want high aspect ratio triangles. They produce really, really good results with the pattern. So if you're working with developable surfaces, you can turn that on and you're going to get meshes that are a little better suited for the work that you're working. So we move down the initial flattening order. When we do any kind of operation in the flattener, when we convert to ExactFlat, or when we do any kind of remeshing operation, immediately following the remesher, we are automatically going to apply a pre-flattener to the result. And the pre-flatteners are applied in this order here. So the first pre-flattener that will be used is fracture. The results will be evaluated, and if there are any folds or wrinkles, we will then try stretch. The results of stretch will then be reanalyzed, and if there are any folds and wrinkles, we will then move on and try pelt. So all three of these pre-flatteners can potentially be used on the pattern piece in an attempt to remove any kinds of folds or wrinkles. If the results of fracture, for instance, do not produce folds or wrinkles, then the algorithm will simply stop and the fractured result will be used as is. So ExactFlat would use up to all three of these in this order in an attempt to try and produce an initial unoptimized 2D flat pattern that does not have folds or wrinkles. And you can change the order of these simply by selecting them and pressing the up or down arrows. That will allow you to change the order. So if you know that you're working with parts that are near developable, fracture is a very good first option. Stretch is usually a good second option, and pelt, it doesn't produce the patterns that are visually appealing. Usually they have the most visual distortion and strain. However, pelt is usually guaranteed to produce a pattern that does not have any kinds of folds or wrinkles. So it's a very good last option. Moving on to our optimization settings, this is where we can control the behavior of the pattern optimizer. First option here, preprocessor. This is more of a legacy option from when computer hardware was much more limited. ExactFlat was originally designed about 20 years ago, so CPUs weren't very fast, there wasn't a lot of RAM. And so preprocess is an option that will do a lot of upfront calculations and store those calculations in memory as a lookup table during the optimization process. The reason there's an option to turn it off is because if your computer didn't have enough RAM, then you weren't able to use the option. But nowadays, every computer has plenty of RAM. CPUs are very fast, so there's no reason to turn that off. Just leave it turned on. It's going to speed up the performance of the optimizer. Allow Newton steps and allow quadratic steps are additional metrics that kick in during the optimization process. There's really no downside to having them turned on other than they may take a little bit longer. But again, with modern computing hardware, the performance difference or the performance impact is negligible. If they're turned off, your pattern might not look quite as nice. But if they're turned on, they may improve the quality or the fidelity of your pattern with minimal performance impact. Rigid differential is another algorithm that will kick in, and that will make an attempt to detect very long, narrow, skinny surfaces. And with this turned off, ExactFlat has a tendency to introduce a slight curve to those surfaces. So if you're flattening, let's say, like a steering wheel or something where that's flattened as typically a strip, a rectangular strip of material, ExactFlat will have a tendency to introduce a curve into the pattern. With rigid differential turned on, that will help mitigate that effect and ensure that your pattern that should be a rectangle will be flattened more as a rectangular strip of material. So it's recommended to always leave this turned on. You're just going to see much better quality patterns. It helps preserve symmetry and all that kind of stuff. Our last option here, no seam stretch. This will enforce a constraint such that the perimeter length of the 2D pattern piece must be the same as the perimeter length of the 3D model piece. So with that turned on, it does operate based off of a tolerance here. ExactFlat will always meet or exceed this tolerance here. So the default, I believe, is 10 millimeters, which means that when this option is turned on, ExactFlat will try to ensure at the bare minimum that the perimeter length of the 2D pattern piece is at most 10 millimeters more or less than the perimeter length of the 3D model piece. Usually ExactFlat will far exceed that value, and your difference is going to be closer to 0. So if you need to ensure that your perimeter lengths are always exactly the same, if no stretching at all is permitted, then you can turn that option on. And we recommend starting at the default 10 millimeter. If you're finding the deviation is still too great, then what you can do is come back and slowly reduce this value. You never want to set it to 0. You never want to just set it to a very, very small number. You always want to make small changes. So I would recommend if you're starting at 10, then maybe cut it down to 5. Then if that's still too much, then 4, then 3, then 2, and so on. If you get too aggressive with your no seam stretch tolerance, your pattern edge may actually start to look more like crocodile teeth, where it has a kind of a serrated saw blade appearance to it, and that's because ExactFlat can't resolve the strain, so it's artificially deforming the perimeter of the pattern piece just to meet the constraints. So make small adjustments. If you notice that you're starting to get edge deformation, then back off, raise the tolerances a bit. And if you're still finding that you have too much deviation, that's a good indication that you may need to introduce a cut into your part, or even a dart or a relief cut. Probably the best thing to do would be to split your pattern piece in half and try again, because there's probably a certain geometric feature in there that's just introducing too much strain. Moving on to the pattern tab. This is where we can adjust most of the defaults surrounding the seam and hem tools. The default edge type allows us to adjust the default seam or hem or bound edge that is automatically applied the first time we open up the seam or the hem tools. At this point, we should talk a little bit about global properties versus document properties. Most of the settings that we adjust in the ExactFlat Options panel will adjust the global properties that are applied to every single new part that is created when we click the Convert to ExactFlat button. When we click the Convert to ExactFlat button, a lot of these options are copied to the document properties that are stored with the actual document. And when we start adjusting things in the seam and hem PNPs, we're actually adjusting the document properties. So if you make a change in here, it's not necessarily going to affect your document if you've already started your patterning work. These changes only are applied to new documents created when you click the Convert to ExactFlat button. So with that in mind, we can adjust the default seam for any new document by simply changing the value here. If we're not happy with 1/2 inch pinch, we can change that to, for instance, a 6 millimeter join. Same thing here, we can adjust our default hem to whatever we want. We'll pick 2 inches there. And if we had bound edges in our database, we'd be able to pick a default bound edge. Similarly, we can adjust the default notch chain setting. So if we always want notch chain, we can turn that on. We can adjust the type of notch that is automatically created. We'll pick 4 millimeter slit. And we can adjust the method that is used to create our notch chains. So if we want a set number of notches, leave it at count. If we want them at an interval, set it to spacing and adjust your counts of spacings. So we scroll down, we have our default hardware and markings. So this is the same as seams and hems. We can just adjust our default hardware and markings. Right now it's set to button. And for marking, it's set to general marking. I might want to change that to sew line, or whatever one is best for your organization that you're using the most. Lastly, we have our default notch. So this does not apply to notch chain. This default is for this tool right here. For precision notches, we can adjust our default notch type right here. When we send our patterns to the nesting, manual nesting or automatic nesting, nesting is always done as polylines. So we do take the spline or curve boundaries of the planar surface and we tessellate those into polylines. And that tessellation is done according to these parameters here. You can adjust the chord tolerance. This is the maximum allowed distance between the curve and the midpoint of any resulting polyline segment of your polyline. And we can adjust the minimum line length. So this would be the minimum length of any segment on the polyline. So when we create a polyline, we're going to constrain the polyline so it meets all of these parameters here. When we create a drawing from our part, we can adjust the size of the symbols used to represent the different notches on the drawing by adjusting these parameters here. So if you'll recall, when we created our drawing, all of our notches were represented by circular symbols on the part. We can adjust the relative size of those symbols by changing the pixel size here. And when we print the drawing out, we can adjust the size of the symbol on the printout by adjusting our symbol print size. Our next configurations are the grain lines, and this is where we can adjust the default behavior of the ExactFlat grain line. Unless we explicitly set a grain line using the grain lines tool, ExactFlat has to do something to automatically create an automatic grain line for us. The default behavior is to use the current horizontal axis. So we're not in our pattern view right now, but if we were to go to pattern view right here, we can see our red x-axis right now. And with current horizontal x-axis set as a grain line mode, it's going to project this red line onto the pattern piece, and that will become the grain line. So now if we go to view markers, we can see our grain line. We can see our pattern piece in the exact same orientation as it is there, and we can see our grain line, the x-axis that we're projected on. The other option is, scroll down, use initial horizontal axis. So with this option, again, the x-axis is projected onto the pattern pieces immediately after conversion, but that grain line is locked into place. As you rotate your pieces, the grain line rotates with the pattern pieces. This differs from current horizontal axis in the sense where with this option here, the grain line is floating. So even though, if we, again, we'll look at markers here, we can see our grain line is perfectly horizontal. If I were to now rotate this piece using the Move Pieces tool here, so we've rotated that piece quite a bit. If we look at the view markers again, our grain line is still the x-axis. So with this mode, you can rotate your pattern pieces and you can align the grain line so it's the pattern pieces lined up so the grain line is always going to be projected on as the x-axis. It makes it a little bit easier to control the orientation of your grain line. Ultimately, though, the most control is given by the grain line tool here. However, we do strongly recommend that if you're going to use this tool, it has to be the very last operation that you apply. Otherwise, it will introduce instabilities into the workflow. Moving on, one of the features of ExactFlat allows us to apply edge labels within the seam allowance of our parts, and we can adjust the defaults for those edge labels using these settings here. So they're turned off by default. If you do want edge labels, then you can configure them here. And what happens is when we create a seam, these edge labels are copied over to that seam. So each seam has its own unique set of edge labels. So we're just adjusting the default settings that will be copied over. If you want them on, click this button to turn them on. Then you can configure your edge label. And every single time we create a seam, they will be copied over to that seam. The last option here is the export dialog setting. So this is, again, a specialty setting for when we click the export pattern button. What that's going to do is it's going to save our part as a new SOLIDWORKS part file. It's going to append this suffix to the file name. And then if this option is turned on, the export settings dialog will appear. This is a very specialty tool designed for the pool and spa industry, and the primary goal of this setting is when we click the export button here, it's going to first save it as a new part file, and then we get this settings dialog here. From here, we can turn on panelization, so we can split up our panel into thin strips of material, and we have some controls for automating the downstream process of converting to ExactFlat, choosing our material that's automatically applied, how we want our pieces to be ordered on the document, and so on. So it's a specialty tool for the pool and spa industry. So we can turn on or off whether this setting is controlled with that option. So we'll close this. We'll go back to, actually we're going to reopen our share file. Okay, so moving on, we have our markers tab. And from the markers tab, we can adjust a lot of the default behavior of the markers and how markers are created. When we click the Convert to ExactFlat button, the default behavior is for ExactFlat to do the initial flattening. We then ask you to pick a material, and as soon as you pick a material, ExactFlat will automatically create a marker set. It will automatically add one marker for every single material selected, and then it will add all of the pattern pieces to the correct marker. So ExactFlat does a lot of automation in regards to helping you create your markers. You can turn these automations off. So if you don't want ExactFlat to automatically place your pieces onto the marker, you can turn off the auto place marker pieces on marker option. If you don't want ExactFlat to automatically create a marker for you when you assign materials, you can turn off the auto create markers on marker set creation. If you don't want ExactFlat to create a marker when you assign a material, turn off the first one here, auto create markers on material assignment. And if you don't want ExactFlat to automatically create a new marker set or a new marker when you create a new marker set, then you can turn off the second option here, auto create markers on marker set creation. You can have multiple marker sets. ExactFlat is configured where you have a marker set which contains multiple markers. This allows you to run different simulations on different types of markers, different materials, different quantities, and so on. And you can adjust the default marker set copy count from this parameter here. We recommend always leaving this set to 1 though. Reason being is you get more control. You can set the parent multiple in the marker controls, and that's a much better way to adjust the number of pattern pieces that are going to appear on your marker. When we are finished with the marker and we want to export our pattern as a DXF, we have to pick an export profile. And we can adjust the default export profile that is automatically selected by ExactFlat from the options panel here. So usually it's best to set this to your own cutting table type. So whatever your cutting table may be, if we have an autometrics cutter, we might set this to the autometrics profile, and that way when we click the export button in the marker interface, autometrics is automatically going to be selected. If we have any kind of text on our marker, we can set the height of that text using this parameter here. So this will control the height of the text that is exported to a DXF. Our last option down here, it controls the way pattern pieces are placed on the marker. The first option here, auto rotate piece to minimum height, will attempt to rotate the piece such that the width of the piece is at a maximum and the height is at a minimum. The reason we do the rotation is it increases the chances of the piece actually fitting onto the marker. If we look at our marker, it's usually a very long, thin strip of material. So it's best to orient the piece in that same orientation to maximize the chances that it's going to fit onto the marker. When doing manual nesting with the box packer too, this also tends to produce the best, most efficient nests, as additional pieces can be nested or packed on top of the first piece. It's worth noting that this rotation is only going to occur if the constraints of the piece lay rule or the piece constraints will allow it. So if your constraints are set to any way, any rotation is allowed, then auto rotate is guaranteed to work. However, if your constraints only allow 180 or 90 degree rotations, then auto rotate is not guaranteed to work. If the automatic rotation falls outside of the constraints, then the automatic rotation will fail, and your piece is going to appear exactly as you see it in your pattern view. Normally, pattern pieces are rotated in a counterclockwise direction to get them to fit the minimum width. However, we can adjust the directional tolerance here. So if we need, with the way this is set, it's set to 1/10 of a degree. So if we only need to rotate our pattern piece 1/10 of a degree in a clockwise orientation to get it to the minimum width, then clockwise orientation will be used instead. So if the required rotation in a clockwise direction is less than or equal to this value, then the pattern piece will be rotated in a clockwise orientation. Otherwise, it will be rotated counterclockwise to get it to fit onto the pattern, the marker. The implications are for this, there's always going to be two orientations that meet the minimum width, and if you rotate 180 degrees, you'll get basically a mirrored rotation. So you can control the default orientation with this. Collate bulk pieces on bulk placement. This is very similar to collation when you're printing your pattern pieces. In the typical workflow, when you add, let's say we have multiple pattern pieces on our document, if we add them all, it's going to add all copies of piece 1, then all copies of piece 2, then all copies of piece 3, and so on. If collate is turned on, it will add one copy of piece 1, then a copy of piece 2, then a copy of piece 3, then it will add the second copy of piece 1, the second copy of piece 2, the second copy of piece 3, and so on. So if you want collation, turn that on. If you don't want it, leave it off. And again, these settings are more for manual nesting. If you're using automatic nesting, Fraunhofer is going to take over and just re-nest your marker for you anyways. The default placement is set to none, and to show this off, what I'm going to do is I'm actually going to cancel here. And I'm just going to go ahead, I'm going to create some pieces first so we can have a look at the what a normal marker would look like. So I'm just going to create some pieces here. I'm using a default names, and I'm just quickly creating a marker for us. So we'll select all those pieces there, and we'll make sure we get all these pieces there. We'll quickly convert to ExactFlat here. And I'm just going to run through these steps really quick, and we'll come back once it's done. So I'm just quickly arranging our pattern here, just so we can really explore the effects of the default placement options. Okay, so we have our pattern, we have it arranged, and the first option we are going to look at, if we come back to markers here, is the piecement placement method none. So these options here, they affect the global defaults applied that are copied over to any new document when we click the convert to ExactFlat button. So adjusting these methods here, the placement method here, is not going to have any effect on marker for this document here because I've already converted it. These settings have been copied over to the document. So these simply affect the global defaults. However, we can adjust these on a per marker basis, and we'll have a look at that next. So we're going to leave the ExactFlat options now. We're going to go to the marker view. We have all of these exact same settings in the marker view, and we're going to examine these settings from within the marker view. So over in view markers, we can see that our marker looks exactly the same as our pattern environment. And that's because the piece placement method is set to none. If we change this to box packing, for instance, and we repack our marker, ExactFlat is going to make an attempt to automatically rotate our pieces to the minimum height, if possible, and place our pieces onto the marker. So we can see that we're making a very simple, primitive attempt at nesting our markers, our pieces together. The next option, linear left to right, does pretty much exactly what it sounds. It just arrays our pieces from left to right across the marker. Right to left will do the exact same thing, but just in reversed order. And then there's our last two options, salvage left to right and salvage right to left. They're just specialty options designed for the pool and spa industry, and their goal is to handle very small pieces a little bit differently. But probably the most two useful ones are none and box packing. If you're using automatic nesting, I typically leave this at none. If your goal is to export the DXF and nest it elsewhere, it's best to leave it set to none. That way your pattern pieces are in a recognizable format, and your nesting software can just pick them up and rearrange them however it wants. The other two options, linear placement alignment, this defines where our pattern pieces are going. So we're looking at a left to right alignment here, and our placement alignment was set to middle. If I set this to top, it's going to array our pieces across the top of the marker. If I set this to bottom, it's going to array them across the bottom of the marker. And then our last option, placement failure behavior. This defines where pieces are going to be placed if they cannot be rotated within the constraints of the material, the lay rule, to get them to fit onto the marker. So if we were to automatically adjust and manipulate, if our material wasn't wide enough to accommodate these pieces, then we can adjust where they go. Do not place will simply not place them on the marker. They will remain in inventory down here. So that's not the recommended method, because it's unless you're very careful and meticulous about checking your piece quantities, it's very easy to miss a piece that has not been added to the marker, especially if you have a very, very large marker. The other option, place at origin, it will just place every single piece on the origin. Again, that's not the most recommended method because it may be difficult to see how many pieces are there. But our last option, place above marker, it will array the pieces across the top of the marker in a very visible, very easy to see fashion. So this is the recommended option here, place above marker. So we're going to leave the marker now. We're going to go back to the options. And that's it for the marker options. Our next tab is costing. And this is where we can adjust the currency used for basic costing. So if you have ExactFlat Professional, you can set your default output currency here. So if you always want your reports in US dollars, you can set this to US dollars from the list. There. Our database tab, this is where we can set the default database used by ExactFlat. If you have multiple databases installed, you can pick which one is the default. That's always going to be used when you click the Convert to ExactFlat button. If your database is a shared database, such as a shared SQL Server database, then you can optionally turn on the Refresh Database on Startup option, and this will make an attempt to synchronize your local copy of the database with the remote database whenever you start up ExactFlat. If you are using Production Manager, you can set some of the default preferences used by Production Manager here, such as default site, default currency, and default unit system. The unit preferences, you can't adjust these. These are just previews for the unit system here. So if I change my unit system, we're going to see all these units updating to basically show us what our different dimensions are going to be measured in. Lastly, we have our database log entry option. With this turned on, whenever we make a change in the ExactFlat database, we are going to be asked to log the change, both your name and a description of the change. You can turn that off, and that will disable logging. ExactFlat will automatically generate a basic log with the date and time that the change was made, as well as the computer name that the change came from, but it will lack the reason for the change. So this is a personal preference for your organization. If you don't want logs to be created, you can turn that off. So our last tab here allows us to control the localization of ExactFlat. ExactFlat only really comes in English. However, if you did want to localize it to your own language, you can create your own language files and place them in the localizations directory, and then your new localization will appear in the list here. ExactFlat only ships with English, so in most cases there's no need to come in here. You don't need to change the localization. So that covers all the different tabs in the ExactFlat options. The last thing we're going to talk about are these buttons over here. So if you have multiple workstations in your organization and you want the same settings in use on every single workstation, you can configure the ExactFlat options once on a workstation, and then you can click the Export Add-in Options button. This will export your add-in options as a DXF, or an XML file. And you can then take that XML file to another workstation, and you can click the Import Add-in Options, and you can import those options, and that's a very easy way to pre-configure options on many workstations so they are all uniform. Similarly, if you have your databases all configured on one workstation, if you have a shared database, for instance, you can simply click the Export Database Options button, and again, that will create an XML file with your database options, which you can then import on other workstations. So that's it for the ExactFlat options. Next, we're going to move on to the ExactFlat Database Manager. So as we create things like seams, all of our seam types are, pick an edge first, all of these seam types are stored in a database, and we can modify these seam types using the ExactFlat Database Manager. The ExactFlat Database Manager is accessible through the Windows Start menu, so just click the Start button, and if you just start typing in Database Manager, usually it's the very first item in the list, so we'll open up the ExactFlat Database Manager, and we'll have a look at this. So, for default installation, we're only going to have one database here. It's going to be the sample database. However, if your organization is a large organization and has a shared database on a SQL server, you may have a second option here for your shared database. There's some basic things we can do to the databases from here. If you want to remove a database, you can click the Remove button, and that will remove the database from your list. If you want to create a new database, you can click the Create button, and this will launch the database creation wizard. A local database is a database that's stored on your computer. It's only accessible by you. Other users on your computer do not have access to that database. So all you do here is you just give it a name, click the Create button, and ExactFlat will create a new database. It will pre-populate that database with default data for seams, hems, materials, and so on. It's just a very fast, easy way to get started with a new database. The other option, SQL Server Shared, this will create a database on an actual SQL server. We strongly recommend that you create a new privileged user specifically for ExactFlat, and you use these credentials here. Some people simply use the administrative credentials, others use the database administrator. We recommend you create a new ExactFlat user with privileges that allow you to create a new database. So you'd enter in your SQL Server username, server password. You can use Windows authentication. We don't recommend it though. We recommend you use an SQL Server username password instead. But if you have Windows authentication set up, then you can use that. And then you give your database's properties. So you have to specify the instance name of your SQL server, and then this is the new database name that you're going to be creating. you create, ExactFlat's automatically going to create an SQL user for that particular database, and you can specify what you want that username and password to be, and confirmation, of course. And just like with local database, when you click the Create button, ExactFlat is going to create a new database for you, pre-populated with all of the template data of the ExactFlat standard database. Just like within the ExactFlat options, close my PNP here. So just like over here in database, we have our default database option here. We can also set this default from the database manager. So we can simply select our database over here and click the set default, and this will apply the default flag to our selected database. If we already have a database in existence, but we just want to add it to our list here, we can click the Add button, and this will add whatever values are down here to the list as the registered ExactFlat database. So if you're doing a backup or a restore, this is a good way to add this database to your list. So once we have our database created, we can then connect to our database simply by selecting any of our databases in the list. And if we click the Connect to the Database button, that will connect us to our database. Once we've been connected, we now have full access to our table editors and our management tools. We'll start with seams, hems, and bound edges. These are all defined in the Edge Features data table. So we can open up a data table either by selecting it from the list and clicking the Edit button, or we can just double click on the table and that will open it up as well. Once we are in the list, we have access to all of the different edge features. Seams, hems, bound edges, and raw edges, they are all considered edge features, and they share pretty much all of the same properties, so they are all in one table. As we scroll through the list, we can see all of our different properties here. We can see the name of the feature, the description, and most importantly, we can see the type of the feature. So the first ones here are all seams, and as we scroll down, we can see more hems, and we can see custom seams that have been added down at the bottom here. If we want to remove a seam type, we can simply right-click on the row or click on the row and press the delete key on your keyboard, and that will remove that seam type from the table. If we want to add a new seam or hem type, we can do that just by clicking down here in the box with the little asterisks, and now we can start entering our new seam parameters. So if we wanted to do, say we wanted to create an asymmetrical seam where we have 5 millimeters on one side, 10 millimeters on the other, we can do that from here, and all we have to do is give it a name and description. So we might want to call this 510. This is going to be created as a seam. Over here for our first allowance, we'll set 5. For a second allowance, we will set 10. We'll make sure we set our units. So this is millimeters. We are going to leave the symmetric flag unchecked. We want this to be created as an asymmetrical seam. If the symmetric flag is checked, it only ever uses the first allowance, but if it's an asymmetrical seam, it will apply the allowance 1 to the left and allowance 2 to the right. And then lastly, we set our default end condition, trim extend, and our default color. Pick line. And now when we click save, make sure we pick seam, and now we can click save, enter in our reason for the change, and click OK. Now, any new part that we create using the sample database here will be, we'll have the ability to pick that new custom seam type from the list, and anyone who wants to use that seam type can use it. Marking features is where we can add new markings. So when we start creating our hardware and markings, the marking feature here, this is where all of our different marking types are. These don't change the way ExactFlat exports anything to a DXF. They are simply here for drawing tool purposes. If you apply or if you create a marking table, then the marking type can optionally be included as part of that table to help you identify what your different marking types are. Material Layrules. these adjust the allowable rotations of our pattern pieces on a marker. So these are the different sets of constraints. So each material has a lay rule, and a lay rule is a named collection of piece constraints. So from our lay rule, we have our rotation tolerance, our rotation increment, whether the material is double-sided or not. We can turn on or off, allowing in the flipping in the X or Y direction. So if your material doesn't have a nap or a finished and unfinished side, then you may optionally turn on flipping, allow flipping X and Y for more efficient nest. We can also adjust the default edge buffer and the default piece gap, as well as their units from here. So just like with the edge features, we can delete any of them just by selecting the row and pressing the delete key, or we can add a new lay rule by filling out all the information in the row at the very bottom with the asterisk. Notch type is our last data table. From here, we can adjust the different notches included in ExactFlat. You can't create new geometry types. You have to use the geometry types that ExactFlat provides. However, you can modify the default width and the default depth of the notch to make their dimensions more compatible with your project. And just like with edge features, marking features, and lay rules, you can remove a notch feature by selecting the row, clicking the delete key, or you can add a new one by scrolling down to the bottom, the very last row with the asterisk, and entering in your parameters. Moving on to the management tools. The first management tool is the hardware category manager. So when we go to add hardware, there's a lot of different hardware types, and they are organized into categories. So from here, we can add new categories, and we can drag and drop different hardware types into the different categories. So this is very much a drag and drop operation. So if we wanted to move, for instance, the J hook into the buttons category, we just drag and drop that into the buttons category, and now J hook appears. When you're done, click the Save button, and that will save your changes to the database. As for the actual hardware types, that's controlled through the hardware type editor. And from here, this one looks very much just like a data table. We can just scroll up and down. And this is managed exactly like a data table. This is where all our different hardware types are. We can change the name, description, reference geometry. So some hardware types, like ISO buttons, you typically measure those in terms of quantity or the number of buttons. So they're typically represented by point entities. So that's why our reference geometry type is set to simple point. Whereas something like an elastic, you might measure that more in length, so meters. So for things like simple elastic, we measure that as simple line. Our options here are simple point, simple line, mated point, and mated line. With mated, it's simply going to cut your quantity in half, recognizing that you may have a mated quantity in there. You might have 2 points representing each half of the object. The last option down here, block. If you use sketch blocks to represent your different hardware types, so for instance, if you have some kind of buckle assembly, you might have a sketch block that represents the buckle. And block will set it so instead of measuring the length of the segments or counting the number of points in that block, it's just going to count the number of block instances as point objects instead. So you can set it to block if you're using sketch blocks to represent your different hardware types. And then lastly, we have color, and the other settings are more for information purposes only. Item number, site, default cost. If you're using basic costing, you can set the default cost of your hardware item here in its currency, and that will go in through our costing system. And just like with the other data tables, if you want to remove a data type, just select the row, press delete. If you want to add one, scroll down to the bottom of the row with the asterisk, enter in your parameters, and then you can click the Save button to save your changes. The Material Manager, this is where we can add different materials to ExactFlat. So when we open up the material manager, it's divided into 3 different columns. We have our categories on the left, we have our materials in the middle, and then we have our properties on the right. So we can add or remove different categories by clicking the Add and Remove button over here on the left. This will either add a new category to the list, which we can drag and drop however we want. Or we can select a category, we can click the Remove button, and that will remove that category. We can select the different categories, and we can drag and drop our different materials into those categories. We can also drag and drop materials over here in the category tree. Similar to categories, if we want to add a new material, we click the Add button. That will insert a new material into the material manager. And if we want to remove a material, we just select the material from the list and click the Remove button, and that will remove that material from the list. On the right-hand side, we have our properties. So for every single material, we have basic properties such as our general properties, name, description. You can enter in item number, site, default cost, and so on. Most of these are just for information purposes only. The cost will be used by our basic costing if you are using ExactFlat Professional. So you can enter in your cost and the currency that you use to pay for that particular material. Nesting is where we can modify the settings associated with nesting. So we have default width and max length. And the way we define whether this material is using bound surfaces or not is whether we have a max length defined. If our material has a max length set, then by default ExactFlat will be configured to use bound surfaces. If we leave this empty, then ExactFlat will be configured to use an infinite length marker. It will turn off bound surfaces. And of course, we can change the default units for those measurements. Below that, we can set the lay rule for the material. So all we do here is we just pick the lay rule. So if we change this to one way, we can see the constraints that are in play here. We can't actually change any of these. These are just preview items to show us what this lay rule is comprised of. So one-way rotation does not allow any rotation at all. Two-way is only allowing rotations in 180-degree increments. Four-way is allowing rotations in 90-degree increments, and so on. So you can choose the lay rule that you want to apply to your mesh. ExactFlat doesn't actually use the XY origin offset or repeats, so we don't recommend changing these, just leave them blank. Otherwise, you may experience unexpected results. Moving over to physical properties, this is where we store the physical properties that are used by ExactFlat. So ExactFlat does maintain a separate list of physical properties, and this list is separate from our actual material properties over here. The reason being is we might have 5 or 10 different variations of cotton where the material is exactly the same, but the only difference is the color of the cotton. So you might have white cotton, red, blue, green, yellow, orange, and so on. The material properties for all those different colors of cotton are exactly the same, but the only difference would be your inventory item number to match the color. So for those cottons, you'd have them measured once. You'd create one single set of physical properties here, and then for all 10 different colors of cotton, you'd choose the exact same set of physical properties. If you have a new material that you've just had tested and you want to add it to the database, you can click the New button here, and this will insert a new set of physical properties into this list, and then you can modify all the parameters for that set of physical properties. The report that you receive back is very explicitly going to tell you the Young's modulus X, Y, and bias right at the top of the report. Just simply copy those values into this database manager here. Make sure you set your material thickness and thickness units. And then down here, make sure you set your metric to linear isotropic. Once you've done that, you can then go ahead and click the Save button, and that will create a new material. Our last tab, Special Properties. These aren't used by ExactFlat. These are simply for informational purposes only. If you want to add a custom property to this material, Perhaps you want to include the vendor contact information. You can do that using the special property, but again, these aren't actually used by anything in ExactFlat. Once you've finished making changes or creating your material, click the Save button, and this will update the database with the changes you've made. Our next manager is the Costing Manager. This is where we can adjust our currencies. So from here, we have a list of all the different currencies supported by ExactFlat, so you can adjust the relative conversion factor from one currency to another. Our next tab is the hardware costs. This is where we can adjust the cost associated with all of our hardware items. And then our last tab is the fabric costs. This is where we can adjust the cost associated with all of our fabrics. Our Export Profile Manager is where we control the export profiles used for generating DXF files. On the left, we have our list of export profiles. From here, we can add new profiles, we can remove the selected profile, or we can clone the selected profile. In the middle, we have our basic profile properties. So we can adjust the name of the profile, we can adjust what type of file it's going to export as. We recommend leaving it at DXF. HPGL produces unpredictable results. So we recommend leaving it at DXF. ASTM is only recommended for use with our pre-built ASTM profile. This will modify the way the DXF is created to make it more compatible with ASTM export standards. However, we don't recommend using this because you will get unpredictable results. Our last two options here, per instance block definitions, will create one unique block definition for every single copy of a pattern piece. So normally, if we had 10 different pieces, we would have 10 different block definitions. And if we had 5 copies of each piece, then we would have that block inserted into the DXF 5 times. With per instance block definitions, we will create 5 block definitions for each pattern piece, and we will insert each of those unique block definitions once. So this is a compatibility option. Some cutting tables want a separate block instance for every single pattern piece. Other cutting tables want just insert entities. So depending on your cutting table needs, you may turn this off. Eastman Easy Cut, for instance, really wants a single block definition for every single pattern piece. So it recognizes, it reads all your pattern pieces in on a per block basis. The last option, no block definitions. If your cutting table does not recognize block definitions whatsoever, you can click that, and it's just going to export your DXF as simple entities with no block definitions. So the implication there is your pattern pieces will not be grouped together into blocks on your DXF. And then lastly, we can give a description for the profile. Over on the right-hand side, this is where our export entities are. We have a basic filter at the top so that we can use to filter our different entities. We're not necessarily turning them on or off with the filter, we're just filtering them from our view here. So we'll leave this set to all. We have a number of different entities that can potentially be included in a DXF when we export our DXF. We don't have to include all of them, and you can export only what you need. So right now we are looking at the Eastman Easy Cut profile. We are exporting the pattern perimeter and the internal perimeters. We are exporting the sew line. We are exporting piece labels, marking points, lines, and text. Grain line, we are exporting all of our notch lines and so on. And if we scroll to the bottom, we're going to see that we're exporting our hardware points, lines, text, our label lines, as well as all the annotations. So this might be too much. You might not want to see your labels. If you really like the profile, but you just don't want to see the labels, you can simply turn off labels, and then when you create your DXF, you're not going to see the piece labels anymore. Similarly, if you export your DXF and you know you've placed hardware on it, but you don't see any hardware in the DXF, simply scroll down to where hardware is and make sure that the hardware is turned on. If it's off, just place a check mark beside it, save your profile, and then the next time you export your DXF, your hardware will be included in the DXF. The most important thing to change with your profile is the layer name and the color. Primarily, the layer name is what's used by cutting table software to assign tools to your DXF. So when you import your DXF, your cutting table software is going to look at the different layer tables and it's going to assign a tool to the layer tables. So anything on the cut me layer is typically going to be assigned a blade tool, probably a wheel cutter or a drag blade. And that's how your cutting table recognizes what parts of your pattern are to be, how to treat different parts of your pattern. Once you've finished modifying your profiles, you can click the Done button. That is effectively a save button, and that will save your changes to the database, and then you can make use of your profile. The Auto Create Sketch Manager is a specialty tool created for the pool and spa industry. We're not going to cover this because it requires very special preparation of your parts. You need to add very specific custom properties to your surface bodies before you convert them to ExactFlat. So we're not going to cover this. It's a specialty tool for the pool and spa industry for some very specific integrations that we've done for them. Lastly, we have our version information here. This is where you can see your database version, and if you are using our production manager on a shared database, you can see your standalone table or your standalone table versions from here as well. So that's it for the ExactFlat Database Manager, and